Okay, so let's do a couple of examples. We're going to find all six, so we will do the secant, cosecant, blah, 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 trig functions. My abbreviation for functions is FCNS, for 5 pi over 3. Okay, so the first thing that I do when I look at this is I say, okay, what quadrant is 5 pi over 3 in? That may not be the first thing that I need to do, actually, but that's one of the first things that I think of. So 5/3 pi, if you think of it that way, 5/3 is almost 2 pi. All right, 6/3 is 2. So 5/3 is going to be in the fourth quadrant here. So that's one of the first things that I make note of. It might not be the first thing that I do. Okay, so we're going to do cosine of 5 pi over 3, sine, tangent, and then we'll do the other ones, but those are easy because you just flip them. All right, so it's a pi over 3. So pi over 3 is a 60. All right, it's not actually 60 degrees, obviously, because it's in the fourth quadrant, but a denominator of 3 always corresponds to an angle who has a reference angle of 60 degrees. So 60 degrees has a higher y value than an x value, so the y is going to be square root of 3 over 2, which is sine. All right, so sine is going to be square root of 3 over 2. Cosine is going to be 1/2, but I know I got to figure out the signs yet. But I know those are the numbers that it corresponds to. All right, so that's how I reason it out. You could draw a 30, 60, 90 right triangle to help you since you know it's a 60-degree angle. You can use, there's a hand thing that you can do. But somehow you need to know that for a pi over 3, sine is square root of 3 over 2 and cosine is 1/2. All right, and you do need to know these without a calculator. So then to figure out the signs, there's a little acronym if you want to memorize it that's all silver teacups or all people take all students take calculus. That tells you which one is positive. So first quadrant, all are positive. Second quadrant, sine is positive. The other two are negative. Tangent and cosine is positive. I just think of the coordinates in that quadrant. So fourth quadrant, x is positive, y is negative. So that means cosine is going to be positive, sine is going to be negative. Okay, so positive, negative. Tangent, here's that trig identity again. Tangent is sine over cosine. So we're going to do, once we know sine and cosine, then we can do tangent. So we have negative square root of 3 over 2 over 1/2. And we don't divide fractions. We multiply by the reciprocal. So we want to simplify that if we can. We can cross cancel the 2. So this is just negative square root of 3. Okay, so then those are our big 3. So then we do the little 3, the other ones that nobody likes. They're the ugly stepchild of the main 3 trig functions. Secant, cosecant, and cotangent. They're just the reciprocals. You have to know which one goes with which. The s's go with the c's. So secant goes with cosine. You flip 1/2, you get 2. Cosecant goes with sine. You flip square root of 3 over 2, you get 2 over the square root of 3. If you want to rationalize that, that's 2 square root of 3 over 3. But I'm fine with you leaving it that way, but you should know, how to simplify it. And then cotangent, you flip that one, negative 1 over the square root of 3, or if you rationalize it, negative square root of 3 over 3. On a test, if you left it with the square root in the bottom, I'd be fine with that. All right, let's do another one just to do another one. We're going to do the same thing, but we're going to do 5 pi over 4. Okay, so first thing I think of is, well, first of all, I look at the denominator and I say, okay, that's a 45. All right, or a pi over 4. Okay, so I know everything's going to be square root of 2 over 2 except for tangent, but sine and cosine are going to be square root of 2 over 2. I already know that because it's a denominator of 4. So then I want to think about what quadrant is it in. 5/4 is a little bigger than 1. 1 is 4/4. So 5/4 is going to put us in the third quadrant. Right, in the third quadrant, both x and y are negative. So both cosine and sine are going to be negative. Okay, so cosine of 5 pi over 4, sine of 5 pi over 4, and then tangent of 5 pi over 4. All right, so cosine is going to be negative square root of 2 over 2. Sine is going to be negative square root of 2 over 2. We knew they were square root of 2 over 2 because this had a denominator of 4. That's a 45-degree angle. And we know they're negative because third quadrant, both x and y are negative. Tangent is sine over cosine, or y over x, if you want to think of it that way with the coordinates. So sine over cosine, if we put these on top of each other, I don't want to write the fraction. It's just going to be 1, all right? Because you have negative square root of 2 over 2 or over negative square root of 2 over 2. So that's going to be 1. So then we do the reciprocal. Secant is going to be negative 2 over the square root of 2. If you rationalize that, that is 2 square root of 2 over 2, or just square root of 2, and negative. And then cosecant is going to be the same thing. You don't have, like I said, I don't care really if you rationalize it or not. You should know how. So if you don't, ask. But otherwise, and then if you take the reciprocal of 1, it's 1. All right, this may be the last example. There might be one more. Oh, I forgot. Coterminal angles, just a quick mention. If you have a negative angle, or if you have an angle that's bigger than 2 pi, remember you find a coterminal angle by adding or subtracting 2 pi. Okay, so for example, if you were trying to find the cosine of negative 2 pi over 3, you'd want to add 2 pi because you want to make that something between 0 and 2 pi. I guess you don't have to if you can figure out what angle that is, but I would probably find the coterminal angle by adding 2 pi first before I found the sine or cosine. That would be my personal preference. Okay, so then let's solve cosine equals square root of 3 over 2. Okay, this is different than just finding the inverse cosine of square root of 3 over 2. Technically, inverse trig functions only have one answer because their domain and range are limited. For an equation like this, though, there are infinitely many answers. All right, because cosine hits square root of 3 over 2, you think of that wave, it's going to hit that square root of 3 over 2 infinitely many times. All right, we're just going to find one. I don't typically do the plus or minus 2k pi thing. We're just going to find 2 answers. So this has 2 answers, at least. I mean, technically it has infinitely many, but we're just going to find answers between 0 and 2 pi because that's typically what we'll do in calculus if we have a trig function. And then, but if you did inverse cosine of square root of 3 over 2, that really only has one answer. So if this was how it was given to you, you would just have one answer versus this equation actually has technically infinite answers. Okay, so square root of 3 over 2, we know it's either 30 or 60. We got to figure out which one. So we know it's going to have a denominator of either 3 or 6. We'll figure that out in a second. The other thing is this is positive. Cosine is the x on the unit circle. So cosine is going to be positive in the first quadrant. Everything's positive in the first quadrant, but also x is positive in the fourth quadrant. So that's where our angles are going to be. This is usually, I kind of think of the quadrants first for whatever reason. I visualize where it is on the coordinate plane first. All right, so then I think, okay, what has a cosine of square root of 3 over 2? What kind of angle? Is it pi over 3, pi over 6? So cosine is your x-coordinate. If your x-coordinate is bigger than your y-coordinate, that's a 60-degree angle. So this is going to be a pi over 3. All right, first quadrant, it's pi over 3. All right, easy to figure out. Fourth quadrant, we know it's going to be something pi over 3. In the fourth quadrant, we want a pi over 3 that's close to 2 pi, but not 2 pi yet. So 2 pi is 6/3, so this is going to be 5/3. Okay, so that's how I figure these out, is I figure out what quadrant it's in. I figure out what fraction, is it closer to 2 pi, is it closer to pi in that quadrant. So third quadrant, you'd want to pick something a little bigger than pi, than 1, a little bigger than 1. Second quadrant, you want to pick something smaller than 1, but bigger than 1/2. All right, first quadrant, it's always going to be pi over 3, pi over 6, pi over 4. Okay, and you're done. Okay, so that is, oh, yeah, I feel like I did this wrong either here or in my notes. I totally did this wrong. That should not be pi over 3, it should be pi over 6. Oh goodness. Your x coordinate, I think I said it and then I said that's pi over 3, it's 60. No. Your x coordinate is bigger than your y, so totally ignore everything I just said. X is bigger than y. That is for 30 degrees, which is pi over 6. Oh, goodness. It's the morning and I'm tired already. So pi over 6 in the first quadrant. Fourth quadrant, you want something that's not quite 2 pi, and when you have a denominator of 6, 2 is 12/6. So we want 11/6. I had the quadrants right, just not the angle. There we go. So cosine is x. X is bigger than y for 30 degrees, not 60 degrees. There we go. Okay, I apologize. Okay, so I think that's going to be it. There may be one thing that we need to address in class and do a quick example of, but otherwise, that's good.